find the absolute extrema on the function on the given interval. F of x equals 1/2 cosine 2x plus square root of 3 sine x on this interval 0 to pi. The first thing we need to do to find absolute extrema is to find the derivative and any critical values thereafter. So the derivative of this thing is f of x equals 1/2, and we're going to have to use a chain rule for this cosine 2x. Cosine 2x, the chain rule, we take the derivative of the outside, which turns into negative sine. You leave the inside alone. And then you multiply to that the derivative of the inside, which happens to be 2x. The derivative of 2x is 2. On to the second term. The square root of 3 sine x turns into the square root of 3 cosine x. So with a little simplifying, you can see that this and this reduce away. And so we have a derivative that is negative sine of 2x plus square root of 3 cosine x. Thinking back to all the trig that you have learned, this sine 2x really is messing up this entire equation if you wanted to set it equal to 0 and solve for x. What we need to do is get rid of this 2x somehow. Enter in the double angle formula. When you use the double angle formula, that says the sine of 2x equals 2 sine x cosine x. This will allow us to rewrite the derivative, f prime of x, in a way that we can easily work with it. So 2 sine of x cosine of x plus the square root of 3 cosine of x. Now we can factor out a cosine x, common factor out a cosine x, and we can get something that is much nicer to work with. Negative 2 sine of x plus the square root of 3. Now if we set this equal to 0 and solve for x, we're solving much simpler equations. We can set the cosine of x equal to 0 and solve for x. And when you do that on the interval from 0 to pi, you get that x equals pi over 2. When you're over here with this other one, negative 2 sine of x plus square root of 3 equals 0, when you solve for sine of x, that tells you that the sine of x equals the square root of 3 over 2. When you subtract a square root of 3 to the other side and divide both sides by negative 2, negative divided by negative gives you the positive square root of 3 over 2. When you solve this equation for x, you will get x equals pi over 3 and 2 pi over 3. From the previous page, I have the critical values listed out here, and the original function and the interval we are taking into consideration. So all that's left to do now is to substitute all of the critical values and the endpoints of the interval into the original function to find where the biggest and smallest numbers are. So we will first do f of pi over 3. For whatever reason, I usually work through the critical values first. So that is 1/2 cosine of 2 times pi over 3 plus the square root of 3 of sine of pi over 3. And when you evaluate this, you will see that you will get 1/2 times the cosine of 2 pi over 3 is negative 1/2 plus the square root of 3 times the sine of pi over 3 is the square root of 3 over 2. So when you multiply these first two together, you will get negative 1/4. And when you multiply these second two together, you will get square root of 3 times square root of 3 is just 3 over 2. So that is plus 3/2. And when you subtract these, you will get 5/4. And if you do this all the way down for the other 4 critical values and endpoints, you will get something that looks like this. From here, you just need to make sure that you are picking the maximum and minimum values. So just for some clarification, 5 over 4 is 1.25, which is the same thing over here. And 1/2 is 0.5, same thing here. So it turns out that there will be 2 absolute minimums, as 1/2 is the smallest value out of all of these 5 y values. And so that means we will have abs mins at plural 0, 1/2 and at pi, 1/2. As for the absolute maxes, there are 2 of them, again, one here and one here, and they happen at pi over 3, 5/4 and 2 pi over 3, 5/4. Now, if you decide to use the decimal approximations for these, that's fine, because 5/4 is exactly equal to 1.25. However, if you get something like a third or a seventh over here in the denominator, you need to use the exact fractions. I tend to use the fractions regardless, so here are the answers for the absolute mins and the absolute maxes for this function on this interval.